Hello everybody and welcome to part 2 of every Python function explained. In part 1 I shared with you about 30 functions. In this part I'm going to share with you the rest of them. I'm going to throw the definition up on the screen. I'm going to give you a quick example of how each function works, and by the end of this you will know some new Python functions, and I guarantee you that you will learn something. With that said, if you haven't checked out part 1, I will leave that on the screen. I will also put it in the description, and make sure you check out programmingexpert.io. That's my programming course if you want to get better at coding, master Python, learn Go, learn about software engineering tools and software design. It really is one of the best places to become a software engineer. With that said, let's dive into the video. All right, so let's dive in here with the first function, which is hash. Now, hashing is used specifically for dictionaries and comparing dictionary keys. So whenever you pass a key to a dictionary or you try to access an object, you're going to hash whatever that key is and then compare that with any hashes that currently exist in the dictionary. If there's a match, then you're going to get the value returned by that hash. Otherwise, you're not, right? You're going to get a key error. Anyways, I can show you how it works here though. We have a random string and we just have a tuple, which is a hashable object. And if I run this, you see we get kind of random strings here, random numbers, which are the hash of these values. Now, one thing to note here is that you can only hash things that are mutable. So I cannot hash a list like this. It just doesn't work, right? I cannot hash a list. Now, can I hash a set? Let's try this. So 1, 2, and I cannot hash a set, but I can hash a tuple. So if you ever need some kind of pairing to be used in a dictionary, then you're going to use a tuple rather than a list or a set or something like that, because a tuple is immutable and hence we can hash it. All right, so the next function that I have here is len. Now this stands for length. You can use this on any iterable object. You can see that we can get the len of a list, we can get the len of a string, of a dictionary, or of a set. Now we can do this for a few other types as well, and we can also implement our own len dunder method on any of our custom objects. So what happens when you actually use this len function is it calls the len dunder method, and whatever's returned from that method is what you get when calling len. So in this case, we'll get 5 when we print this out for C. So if I run this, you can see we get 5, and then of course the appropriate lengths for the other objects. Moving on, we have list. Now this is really just the constructor for the list data type in Python. It allows us to convert something to a list. Now to convert something to a list, we need an iterable object, so something like a dictionary, a set, a string, a tuple, and we simply pass that object to the list constructor. Now, if we're converting a dictionary to a list, that's going to give us all of the keys. So it'll give us 1, 2, and 3, not the strings, but the keys. If we're doing a set, it's just going to give us all of the unique objects in the set. If we're doing a string, then we're going to get every single individual character. And if we're doing a tuple, then we're going to get each element that's in the tuple. So if I run this, you see we get 1, 2, 3, 1, 2, 3, 4. We get every single character in our string, including the space, and then we get all the elements in our tuple. Now, it's worth noting here that you cannot be certain that your elements are going to be in the order in which you have them in your dictionary or your set. So imagine you have a very large dictionary, like we're not just writing out all the values here. You're not necessarily going to get sorted values or the values in the order in which you inserted them in the dictionary. It could be in potentially a random order. All right, so moving on, we have locals. Now, locals is going to give you information about all of the local variables that you have access to here in the file. So if I run this code here, you can see that I get this big dictionary containing all of the different variables as well as their value. So we have the name of this file, which is main. We have a few other things that we don't really need to look at. And then you can see here that I've printed out like the location of the file. So you can see it's on my users, Tim, desktop, every Python function, part 2, and then locals.py. Now I've just accessed that from the dictionary returned by locals, but I also could just use this special name here in Python, which is __ file __. All right, so moving on, we have the map function. Now the map function allows us to map all of the values in an iterable sequence using a function. So what I can do is create a sequence like this. I can use my map function. I pass a function here. Now I'm passing an anonymous function, but you can pass an actual function if you wanted to. And if you were going to pass a function you defined, you would just pass the name of the function. You would not call the function by putting parentheses. So I'm passing a function here, which takes one argument, which is x, and then it's going to raise that to the exponent 2. Then I'm going to pass my sequence. What's going to happen is each element from my sequence will be passed to this function and get added into a new map object. And then what we can do is convert that map object to a list, and now we'll get the squares of every single element from our sequence. Now you can do the same thing here with a dictionary. So I've created kind of a more advanced example, I guess. We have a function. What this function does is it takes items, which is this array or this list, at whatever key is passed to the function, and then it multiplies it by the key. Now, in this case, we're going to have string multiplication, and you'll see what kind of happens in this example. So if I run this, we get all of the squares from 1 to 10, and then we get A, B, 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 and then 4 C's. Now, the reason we get that result down here is because when you iterate over a dictionary, you're going to get every single key. That's what's going to be passed to your map function. So we pass the key, we get the value associated with the key, and then we multiply that by the key. Since the key is a string, that's then going to give us string multiplication, and that's why we get 4 C's, 3 B's, and 1 A. Moving on, we have the max function. This allows us to get the maximum value out of an iterable sequence or of multiple arguments. There's different ways you can call this. First of all, we can pass like a list, and this is just going to give us the maximum value in this list. We can also pass numbers or arguments individually. So I've done that here. We can do the same with strings. Now, when we're comparing strings, we're going to be looking at the ASCII value of each character starting at the first character. So we'd start by comparing each string using the first character. If 2 strings have the same first character, then we will look at the second character and use the ASCII value of that character. Next, we have just passing multiple iterable sequences here. Now, whenever you pass multiple values, so like multiple parameters to this function, they need to be the same type. So in this case, I'm passing 3 lists. And what it's going to do to compare the lists is actually use the first element of these lists. So we'll have this being the maximum element because this list has the greatest first element in it. So just like comparing the strings, it works the same for a list. We can also use this on like a custom type. So I have a custom type here, and I can pass the key function or the key parameter, to my map function. And now we're going to be using this to compare. So we'll pass every single value to this key function, and then whatever the result of that key function is, we'll use to pick the largest value. So let me run this, and notice we get 34, 9, yes, we get 2, 1, as I said, and then we get a custom object. If I were to print that out, you would see that we would get C3 because the value returned by C3 is the largest. All right, so the next function is memoryview. This is a little bit complicated, but you can use this on bytes types and a few other types as well here in Python to kind of dig into the representation of this object. So I have a memory view of my variable x, which is a bytes type. That's what the B stands for here. And I can look at, for example, the first index, which would correspond with B. Now notice that when I print this out, the first value I get is 98. So what's actually stored in memory for the character B is 98, and 98 is the ASCII representation of this character. So if I then convert that ASCII representation to a character, notice I get B, and so I'm looking at this character here at index 1 or position 1. If I try to print out a slice of the memory, I can do this, and I'm going to get a memory view object. Or what I can do is convert this slice to a bytes type, and now I'm going to get BCD, right? So if I'm going from 1 to 4, that would be here. So I'm getting BCD when I actually convert that to bytes. If I don't convert it to bytes, then of course I get the memory representation of that bytes object. All right, moving on, we have the min function. Now this is identical to the max function, just the minimum value. I don't really need to go through this. Note that you can use the keyword here as well. And no pun intended, but you can use key as a keyword, and then that allows you to select the minimum based on the return value of this function. Now next, we're talking about the next function. Now this is similar to the aNext function that we saw in part 1, except this is for regular iterators, not asynchronous iterators. What this will do is give you the next value in an iterable sequence, assuming that whatever you're calling this on is an iterator. So I have my custom iterator object here. Notice that I implement my iter method as well as my next method. And now what I can do is create an iterator, from my custom object. So I create an iterator, and then I can call next on it, and I will get the next value in the iterable sequence. And I can do the same thing using like a built-in object, right? So if I have a list, I can actually get an iterator for this list, and then I can call next on that list iterator and get the next value. So let me show you this. We have 1, 2, 3, A, B, C. Again, very similar to the aNext function, just for regular iterators, not asynchronous iterators. All right, so moving on, we have the object function. This is going to create an empty object for you. If you didn't know, every single class in Python by default inherits from object, so it has some pre-built functionality. It's not super useful, but I will run the code and show you that we can print out an object of type object, and we can view all of the kind of built-in behavior, default behavior for this type. Moving on, we have the oct function, which stands for octal. It's going to give us the base 8 representation of a base 10 number. So if I print these out, you can see that that's what we're getting. Really, you want to be looking at the part after the 0, and notice that you get a negative 0 whenever you have a negative octal value. Don't need to go through this too much more, but this gives you the octal value. All right, the next function I have for you is open. Now, what this does is open a new file. Now, I've put all of the different modes that you can use when opening a file here. I'm not going to go through them. Feel free to pause the video and read them if you want, but let's look at this example down here. So I import the JSON module just to show you how we can kind of save JSON data. Anyways, what I can do is use this open object to open a file in read mode or in write mode or whatever the other modes are. So you put the name of the file and then the mode you want to open it in. In this case, len.py is a file that does exist. Then if I wanted to read all of the lines, I can use the file object returned by open to say f.readLines. This will give me a list of all of the lines that exist. I can print those out and then I can close the file object. Now, the better approach to do this is to use this with, which really is going to give you a context manager when you're kind of using this open function. So you say with open as f, lines equals f.readLines, and then print lines. And now you don't need to manually close the file because as soon as you escape this with block, it's automatically going to close the file for you. Continuing, I just wanted to show you how we can save JSON data. So I'm saying data is equal to and then some dictionary. Then I'm going to open a new JSON file that doesn't already exist. So data.json in W mode, which stands for write mode. I open this as F, and then I can say json.dump and then data, which is my dictionary, and then into the file F, and this will create a new file that has that content. So if I run this code here, you can see that I'm just printing out the contents of the len.py file. But now if we look here, I have this data.json file that I created using the open function. Moving on, we have the pow function. Now what pow will do is raise a base to an exponent. We also have the option to get the modulus of a base raised to an exponent if we want. So if we use the pow normally, we just pass our base and our exponent, and we can get 100. And we can also get 0.01 here if we pass like a -2 as the exponent. Continuing, we have pow with mod. Now, if you pass a third argument here to the pow function, you're going to raise the base to the exponent, then modulus it by whatever this is, so mod 6. And in this case, you can see this is kind of the order of operations. We raise 11 to the exponent 3, that gives us this value. We then mod 6, that's going to give us 5. So when I print this out, I get 100. 0.01, and 5. Moving on, we have the print function. Now, I'm sure many of you know how this works, but we can pass multiple arguments here to the print function. They do not need to be strings, and they will all be printed out separated by a space by default. Now, if you want to override the default separator, you can pass this sep keyword. So if I use a pipe, now hello and world will be separated by a pipe. There will not be a space. Alternatively, you can use this end keyword. You can also use it in combination with sep. And now this means at the end, so once this print statement is done, rather than printing the default, which is an escape character, so \n, you're going to be printing this. So usually what would happen is OK would be printed on the next line. But since now we're not printing this \n, which forces the terminal to go to the next line, you're going to see that this will be printed directly after hello. So let's do this, and notice I get hello world 1, hello pipe world, and then hello, end, and then OK. That's because, again, we didn't have this \n. Now, if I manually add the \n in here and I print this out, now you notice that we move down to the next line. All right, so moving on, we have property. Now, this allows us to protect an attribute by assigning a getter, setter, and deleter. You can see I have those here. Then I have my property function, and I pass my getter, setter, and deleter. You do not need to pass a delete function, and you do not need to pass this optional, description of the property. So now that I've done this, whenever I try to access X on my C class, it's going to use the getter function to return the value to me. When I try to set using an assignment like this, it's going to use the setter function and pass my assigned value to value inside of this function. If I tried to delete, same thing, it would use my delete method or my delete function. All right, so that's that. Now we can also use a newer syntax, which is the decorator syntax. So I can decorate a function, which is the name of my property. Then I can have a setter, deleter, and getter. and this works the exact same as just using the function plainly like this. This is probably the preferred approach right now. It's kind of modern Python, but you can use this property as well. So just to show you here, when I print out var.x, you're going to see that since I haven't assigned a value to x, it's going to give me 1, because that's what the getter says. When I set x to 10.2, it's going to round that off to be 10. So then when I print it a second time, we should just get 10. So we should get 1, 10, and then down here, we'll get the same thing. So if I run this, I get 110 and then 110. This is the exact same example. I've just used the decorator syntax. All right, so the next function I have for you is range. Now, range is useful for for loops or just generating some range that has a start, stop, and step value. You can pass a start and stop. You can just pass a stop, or you can pass a start, stop, and step. So the basic rules are the first value you pass is going to be your start. The second value is a stop if you have two values. If you only pass one value, this is going to be your stopping point. I'll explain what this means in a second. If you pass three values, this is going to be the start, this is going to be the stop, this is going to be the step. So you would start at 1, step by 2, so you go 1, 3, 5, 9, and then you would not go to 11 because that is greater than 10. Now, this stopping value here is exclusive, meaning if I put a 10 here, I'm going to stop at 9. So I stop as soon as I hit this value and do not include this value in my range. Now here, when we just put 10, this means start at 0 and go to 10. So we're going to have 0 through 9 as our sequence. And when we do something with negative here, which is valid, we're starting at -1, going to -10, stepping by -2. So let me print this out, and you can see that these are the sequences that we get. All right, so moving on, we have the repr function, which stands for representation. This gives you the internal representation of a Python object. Now, the way repr works is it looks for this __ repr method. If that exists, then it will return to you whatever is returned from that. So here I have my pet class. I have implemented the repr dunder method. And now if I run this, notice I get pet name equals Billy and pet name equals Sally. Now, the point of this is that this is a debuggable object or debuggable output, which makes it easier for me to read than maybe a string representation. Now, a string representation may just say something like, my name is Billy or Sally. It may be whatever you want to show to the user or kind of a cleaner, nicer looking output. Whereas repr is meant to be something that is your internal representation, useful for debugging. All right, so the next function I have is reversed. This is simply going to reverse an iterable sequence and give you a reversed iterator. Now, this will give you a new object. It will not modify the existing object. So I get 1, 2, 3. It's going to give me 3, 2, 1. However, it's going to give me this reversed object. So if I want to view it, then I need to use list. Now, if you were just going to loop through it, that'd be fine because this is an iterator. So you can just loop over the reversed object returned from here. But in our case, we want to print it out. So I'm just converting it to a list. So notice I can do this with a list, with a tuple, with a string, with a few other objects. But there you go. That is how reversed works. All right. So the next function I have here is round. Now, round is simply going to round a number for you. In this case, if you don't pass a second argument, it will round to the nearest whole number. So we should get 11 here. If you do pass a second argument, this will be the level of precision. So we'll round to the 4th decimal place. If you pass 10, same thing to the 10th decimal place. So when I print this out, notice I get 10, 10.2342, and then 0.828. Notice that it is not adding a bunch of zeros here when we do 10. There is ways to do that, but not with the round function. All right, so moving on, we have the set function. Now, this is the constructor for the set data type. It allows you to pass an iterable sequence, and it will create a set from that. So it's useful if you want to get all of the unique elements in something like a list. Now, one thing to note here is if you try to do something like s is equal to, and then you do curly braces, you may think this is going to create a new set because this is an empty set. However, this is actually going to make a dictionary because both a set and a dictionary use this syntax. So if you want to make an empty set, you have to do new set like this. That will give you an empty set that you can then add elements into. Okay, so we can do this with our list. I just kind of showed a fancy way of initializing a set here. Pass a few different elements, and then I am unpacking the list and putting all of those inside of the set and then printing that out. So this is another way to initialize a set. We can make a new set, and then as I was saying, notice there's a new dictionary. So if I go here, we get our set, and then class set and class dictionary. Again, if you just use the curly braces, gives you a dictionary, not a set. All right, next function I have for you is set attribute or setattr. Now, what this will do is simply set an attribute on an instance of a class. So I create my custom instance. I say setattr c, and then I'm going to say the attribute name is x. Notice I'm putting that in a string. I'm going to set that to 1, and if I print c.x, it's going to give me 1. There we go. All right, so next function we have here is slice. Now what slice does is give you a slice object which you can use to access parts of a list. I don't actually know why you would use this over just using the standard slice syntax, but you'll see here that when I print lst at s, it's kind of injecting this as a slice. So the first argument here is going to be your start, the second is your stop, and the last will be your step. Now, just like the range function, if you don't include a first argument, it's just a stop. If you include 2, then it's your start and your stop. And if you include 3, then it's your start, stop, and step. So when I do 1, 3, start at index 1, go to, but do not include index 3. So I should get 4 and 6. When I do 1, 5, and 2, start at index 1, go to 5, which is the end of the list, but don't include it. Step by 2, so I should get 4 and 8, sorry. So if I run this, notice 4, 6, and 4, 8. Again, kind of weird, but this gives you a slice that you can kind of inject or use when you're accessing a list or any other iterable object. All right, moving on, we have the sorted function. Now, this is going to return a sorted iterable for you. You can use this on lists, on strings, on dictionaries, on, say, nested lists. There's all kinds of things you can do. So what I've done here is just sorted this. By default, it's going to sort in ascending order, but you can do this in descending. Now, this is going to return a new sequence for you or a new iterable. It will not modify the existing object you're calling it on. All right, continuing here, we can do this on a dictionary. Now, if we do this on a dictionary, by default, it's going to use all of the keys. So we'll give us a sorted list of the keys. And if we want to do this descending, then we pass reverse equals true, and this will sort in descending order, not ascending. Now, I can also pass a key function here. And when I do this, it's then going to sort every single element that we have based on the key. So when I pass something like sum, it's going to sum all of the pairs that I have here and then sort by the result of the sum. So whatever sum is higher will be, I guess, at the end because we're sorting in ascending order here. Okay, so let's print this and notice that I get my first list, I get my string, I get my dictionary keys, I get my descending order, and then I get my pairs sorted by the sum. All right, so next function I have for you here is static method. Really, this is a decorator, but this allows you to create a static method inside of a class. A static method is one that does not have access to the class or to the instance. It's really just like a utility or helper function that kind of belongs with or is associated with a class. So notice that I can call this in multiple ways. I can use the dot notation on the class name, or I can create an instance and then call it directly on the instance. When I do this, there's no self keyword, so I don't have access to the instance or the class because there's no CLS keyword. So if I run this, I get 5 and 3. There you go, that is static method. All right, so moving on, I have the string function. Now the string function will return the string representation of an object, useful for converting numbers to strings or just anything else that you want. Now, one thing to note here is that when you call the print function, it's actually going to, by default, call the string dunder method or the string function on every single object that you pass as an argument. So if I pass my list here to print, this is the exact same thing as me converting this to a string first and then printing it out. So kind of an interesting note, but whenever you print something, it calls the string dunder method on that object, and then whatever that result is what it actually prints out. So we can convert many different things to strings. We can convert a set to a string. We can also convert our own custom object by implementing the string dunder method. So if I run this, notice that I get the string representation of my list, of my integer, of my, what is this, a set, and then of my custom object, which is something that I've implemented. Moving on here, we have the sum function. Now this is pretty straightforward, but this is going to sum all of the values in an iterable sequence. One thing you can do here that's cool with the sum function is pass a start value. Now when you do this, you're going to be adding whatever the start is to the sum. So kind of would save you an additional step of doing something like, 5 plus. All right, let's have a look here. When I sum this, I get 37.3, 42.3, even though it's the same list because I add this 5. And then I sum my set, which will be all of the unique elements, and that gives me 50. Next, we have the super function. This allows us to access attributes or methods from the parent class directly. So when I have class parent here, and then I inherit from that in my child class, now super is going to reference all of the stuff inside of the parent class. If you have multiple inheritance, it gets a bit complicated. I won't get into that here. but super is referencing your parent or parents class. So what I can do with my initialization here is I can call the parent constructor by saying super dot underscore underscore init underscore underscore, and then passing any value that's required to initialize the parent class. I also can do something like super dot func, and when I do that, I'm now calling the func from the parent class as opposed to the func that I have inside of my child class. So notice here when I call c.func, it will call this. When I do call parent, it's going to call self.func, which will be this, and then super.func, which will be this. All right, so let's run, and notice I get child, child, and then parent. So moving on, we have the tuple function. This is going to convert something to a tuple. If I do something like convert a list of pairs, then it's simply going to replace the list with a tuple and make this an immutable sequence. So if I run this, notice I get a tuple. It does not convert all of the objects inside of my list to a tuple, just the object itself. Now, if I use this on something like a string, then I get all of the individual characters in my tuple in the order in which they occurred in the string. All right, so the next function we have is type. Now, type can be used in a very simple sense to just get the type of an object. We also can use type, though, to create our own classes. Now, I know this seems a bit weird, and I won't get into it too much, but I can actually use it in this advanced kind of use case to create my own class. So I pass the class name, I pass anything I want to inherit from, and then I pass a dictionary containing all of the attributes or functions associated with my class. So when I say attribute, I am an attribute. Now it creates an attribute on this class. And when I do add one, it now creates an add one function because I'm passing a function here. So if I do c equals class name now, I can use this just like a class. I can access the attribute, and I can call the add function. So if I run this, I get I'm an attribute and 3, and notice I passed 2, it added 1, and well, there you go. Now, if we just use it in the simple sense, we get whatever the class is or the type of the object that we're calling on. All right, so the next function I have here is vars. Now, vars is going to give you all of the variables or attributes associated with a specific object or type. So in this case, I can print out just vars with nothing. And when I do that, it gives me all of the globally accessible variables, which we've already kind of looked at. If we do var and then list, it's going to give us all the attributes associated with this list type. And if we call this on our custom class, then same thing, all of the attributes associated with the custom class. So when I run this here, notice that we get a bunch of stuff printing out, right? So we get name, doc, all this kind of stuff. And then on our own custom object, we get all of the default kind of implemented stuff, right? I know, seems a little bit weird, but there you go. That is how vars works. Now moving on to our final function, which is zip. Now what zip allows us to do is actually group multiple iterable objects together into separate tuples or separate pairings. Now, the way this works is you pass whatever iterable objects you want, and then it's going to loop through and essentially take all of the associated indices and put them together in a tuple. So let me just show you what I mean. If we start here, we can see that we have a zip object, so it gives us a zip iterable. We can also just convert this to a list. But notice that I have 4, 5, 5, 3, 6, 1, 7, 2, 2, 3, 1, 1, and those are all of the indexes that associate with each other. Now we can call this on stuff that is different lengths or different types. When we do that, it's only going to go up to the length of the smallest object. So in this case, I only have 3 elements, whereas here I have 5. So you see that we get H1, E2, and L3. So very useful when you want to group multiple iterable objects together. You can also call this with 3 values or 4 or as many as you want. So if I do this with widths, now notice that I get kind of triplets, right, in a tuple. All right, so with that said, I'm going to wrap up the video here. I hope this was helpful to you and that you learned some new Python functions and some new Python syntax. If you enjoyed, make sure to leave a like, subscribe to the channel, check out programmingexpert.io, and I will see you in another YouTube video.